Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to do a topic that I should have done a long time ago. And I'm going to talk about map reading and navigation. Now, it is very important because you have maps everywhere you go. You have GIS that could make maps. If you're in a cartography, you can make maps. If you're out there surveying, make a topographical map. Maps are everywhere. If you are doing a little land navigation and target practice, you want to use a map. Now, the importance of maps is they help you get to your destination. Now, here's the issue. You have a number of individuals who do not know how to read the map. They don't understand the scales, the legend. There are a number of symbols that you need to look at when you're utilizing a map. Now, of course, there are maps in your phones, but still, you have to know how they work. Now, I always prefer looking at a regular table map, which is the basic. Why? Because if you understand how to read a map table, you can look at it on a computer. Now, something else that would be considered a type of map as well would be construction plans, because you're looking at all of the different elements that go into a building or a piece of infrastructure, such as a road. Now, what I'm going to do, I'm going to go ahead and share my screen. And first, I want to talk about this. What is map reading and navigation? Well, basically, map reading and navigation involves understanding how to interpret information on a map, which we call map reading, to plan and follow a route, which is navigation to a desired location. This includes understanding map symbols, scales, directions, and terrain features, and you must relate them to the real world. Now, when we talk about map reading, the scale and the compass are very, very important because a number of your maps have a north arrow, and you have to understand what scale you're using. Now, let me go ahead and, of course, share my screen again, and we're going to get into this PowerPoint. And we're going to talk about map reading and land navigation. Now, the definition of a map is it's a geographic representation of a portion of the Earth's surface drawn to scale. It uses colors, symbols, and labels to represent features found on the ground. And the purpose of a map, again, it provides information on the existence of, the location of, and the distances between ground features, as you see right here. Now, just so you'll know what I'm reading right here, these are your buildings. This is going to be your distance. Now, right here, what are these little lines? They have elevations. They're known as contour lines. So you have different features, and we're talking about terrain. Now, something you need to understand as well, maps also have scales. Now, your large is your 1 to 50,000. And you have your medium, which is 1 to 100,000. Then your small is 1 to 250,000. Also, a lot of your maps use coordinates. Surveyors, they use maps. And what's important about a map is you need to understand the colors of the map. So when you have black, generally you have man-made features such as buildings and roads. Red and brown, relief features and elevation. I just mentioned contour lines and red light readable maps. Brown, relief, features, and elevation. contour lines on older maps. Then if you have green, it's vegetation, such as your woods, orchards, and vegetation. Then you also have your blue, which is drainage or water. And then red, populated areas, main roads, and boundaries on older maps. Now, when we talk about the terrain features, there are 5 major features on a map. And we're talking about terrain. You have your Hidden Valley Ranch. What we say Hidden Valley Ranch salad dressing, hilltop, valley, ridge, saddle, and depression. That's what we have. Then we have 3 minor, your draw, your spur, your cliff. And then we have 2 supplementary, cut and fill. I like the way they put Hidden Valley Ranch salad dressing. Well, you want to know where that came from. The Hidden Valley Ranch salad dressing, if you forget the 5 terrain features, that's what Hidden Valley Ranch salad dressing means. It means hilltop, valley, ridge, saddle, depression. It comes from Hidden Valley Ranch salad dressing. It's just like in trigonometry. If you don't know what the sine, cosine, and tangent are, there's an Indian acronym that we came up with called SOHCAHTOA. Opposite over hypotenuse. Then we have your adjacent over hypotenuse, then your opposite over adjacent. It helps you remember. So that's what that, if you ever hear Hidden Valley Ranch salad dressing, you're referring to the 5 major terrain features that you see on a map. Hilltop, valley, ridge, saddle, and depression. Again, Hidden Valley Ranch salad dressing is the what we call the phrase for the 5 major terrain features: hilltop, valley, ridge, saddle, and depression. Again, your 3 minor, your draw, spur, and cliff, 2 supplementary, cut and fill. Now, cut and fill, where do you see cut and fill? Generally, cut and fill, you'll see that on a plan and profile sheet. Now, when we talk about cut and fill, we're dealing with soil. You may have an existing elevation. So we may put a building on that existing elevation. So you may have to cut some soil, which take out some soil, or you may add some soil or backfill. And generally, you'll see that dashed line where it will become your new contour. As I move on, I want to talk about the hill. It's an area of high ground from a hilltop, the ground slope down in all directions. So you see the hilltop right here. Then you go ahead and you see the contour map. Where you have the smallest circle, that's your highest elevation. And if you look at it, I'm looking at it from the top down. What's happening? It's increasing. It has a hill. Your hill is right at the top, your peak. Now, when we deal with your valley, you also see the contour lines as well, stretched out groove in the land, usually formed by rivers and streams. Well, this is your valley, and this is your contour map, and it represents your streams, and it also represents your elevations going downward. That's your valley. And we have a ridge. A ridge goes right up to a hill. It's the slope going up the hill. And that's basically on a map, it's utilized by a dotted line. you still have your contour map. We have a saddle. A saddle is basically two hills with a depression. Now, why do they call it a saddle? Because it looks like a saddle. So you have two hills or two mountaintops, and then you have a depression. Now, here's what happens though. The saddle is connected by contour lines. So when you look at the saddle, you have two hills at your highest point, and just like a regular hill, you have your lower elevations going down, but you also have an elevation on the outside because it's actually connecting both hills. That's what a saddle is. It looks just like a saddle. Then you have your depression. It's a low point in the ground or sinkhole. They're represented by closed contour lines that have tick marks pointing toward low ground. And this is your depression right here, sinkhole. This is what your depression looks like right on your map. Then you have a draw. It's a less developed stream course than a valley. There is essentially no level ground and therefore little or no maneuver room within its confines. This is a draw right here. Could be in an area of the jungle or forest. You could even have a small creek. And if you're in the military, you must watch out for draws now. Look at your contour map. Again, that's a little river. It's your higher elevations. Now we're getting to your minor terrain. That's a draw. Then we have a spur, a short, continuous sloping line of higher ground, normally jutting out from a side of a ridge. Here's your ridge right here, and here's your spur. And by the way, you can see how steep this spur is. In fact, when you look at contour lines, the further the contour lines are apart, the shallower your slope is. However, the closer they are, the steeper your slope. And that's what you have in the spur. A cliff, it's a vertical or near vertical feature. It is an abrupt change of the land. The slope is so steep that the contour lines converge into one contour line, or the last contour line has tick marks pointing to the low ground. Let me say that again, because some people might get that confused with a depression. Now, a depression does have the tick marks. You have a sinkhole. But here on the cliff is so steep. You can see what the cliff looks like. Again, it's almost a vertical feature, or it could be a vertical feature. And you look the abruptness in the change of land. Walking, and then all of a sudden you go down. It is steep. Contour lines converge into one contour line. The last contour line has tick marks pointing to the low ground. This is what they're talking about right here. This is a contour line, tick marks pointing to the ground. See the abrupt change of land mass. Then we get into a cut. A cut is a man-made feature resulting from cutting through raised ground, usually from a level bed or a road or railroad track. And then we have a fill, a man-made feature resulting from filling a low area, usually to form a level bed for a road or railroad track. And generally in mountains, you have a lot of cuts and you may have some fills. But in the olden days, when they built roads and railroad, they did a lot of cutting through mountains. I can tell you a mountain right now, if you are in Maryland on I-68 going toward West Virginia, Sidling Hill. Well, it was supposed to put a tunnel there. Well, they didn't. They just put a big cut through Sidling Hill. Also, if you go on to the Pennsylvania Turnpike, it used to have 7 tunnels. Of course, 3 of them were bypassed because they were built 1 lane in each direction and traffic backed up, but they're still there. And you have 4 that are still operational. Well, all of the tunnels in Pennsylvania were built through mountains. But this is what a cut and fill is. And in construction, you will hear that term, cut and fill. Now, if you look at it, valley, if drain, hand spread, depression, not drain, hand cupped slightly, spurs, running down slope from each hill along a ridge, using your hands, cliff, steep, almost vertical slope, hills, saddles, draws, running down slope from each saddle, a ridge, again, mentioned it earlier, a series of connected hills, although I didn't say it in that way. I just said you have 2 hills and they're connected by contour lines that are at the bottom. But you have elevations going up. Now, the big thing you need to understand, contour lines. Elevation in meters, or the elevations could be in feet. 3 types of contour lines. Intermediate, contour lines located between 2 index lines. Supplementary, supplementary, complementary, and supplementary. But we're going to deal with supplementary. They're contour lines placed to specify half of a contour level. So you have your intermediate, then you have your full, of course. Or your full that's known as your index. Your index is usually a whole foot. Example, contour level, 20 meters, 100 meters, 120 meters, 130 meters, and 140 meters. Supplementary contours, 10 meters. And you'll see all this on a map. Index are major elevation points, and they have an elevation number written within the contour. Example, 100, 200, and 300 meters. Finding points. All you have to orientate, you have to basically take a map. Now, if I'm traveling on a road and have a paper map, and generally you can always find this out on a map. There's a true north arrow, but you have to know where north is. So actually, you look at your north arrow, it's actually a relative north. True north is actually pointing up to the North Star. That's true north. We generally travel in relative north. So what you need to do in order to find which way you're going, there's a north arrow. Point that north arrow. Could be on a route. Sometimes if you're on a route, a state route or US or an interstate, it'll tell you. But what you do, you orient the map. Compass or terrain association. Compass technique. Cheek and center hold methods. Grid coordinates. Grid zone designator. Number sequence, 4-digit, 6-digit, or 8-digit. Remember, right, then, up. Remember, right, then, and up. Dead reckoning. This is what a compass looks like. Got your lens. Got your magnetic arrow, your short luminous line, your fixed index line, your luminous sighting dots, your sighting wire, cover, base. You have your graduated straight edge, your bezel ring, your floating dial, thumb loop. Now in the military, you use a lot of compasses. Your lens or rear sight. This compass is very important because if you have a map, you're going to use that compass to navigate through terrain that you're not even familiar with. But if you have the map, you can do it and you can do it correctly. There are a few things you need to know. And one, you need to know how to utilize the compass. Now, of course, compass right here has 5,550 mils. Now, what is a mil? Well, a mil is used for shooting a weapon. That's a unit for shooting a weapon. Like if I'm going to set up an M60, well, I need to know how many mils this gun can shoot. So you have your mils, your maps have mils, and this is what your Army maps have on it. This is where they plan to hit certain targets. And you have your index line, the black ring, the red ring, the floating dial. Compass technique. Well, the compass to cheat technique is used almost exclusively for sighting, and it is the best technique for this purpose. And the center hold method is much faster but less precise. So what they're doing, they're using the compass to cheat method and the center hold method. You always have to make sure that your compass is set at 0 as well. Then you have to orient the map. Here's what the map is. Now we're doing some military because you have a military protractor. Again, I told you about mils. Well, here's your military protractor, degrees, baseline, your index. Just like a protractor. Regular protractor, you get protractors in 360 degrees or 180 degrees. This is a square protractor. Grid coordinates. To locate any coordinate must go right, then up. So in other words, 4-digit coordinate located within 1,000 meters, RP 5904. So what am I going to do? I'm going to go 5904, or is 59 right here. So I'm going to go up and then right. Put me right here. It's 59 and this is 04. Up and right. It's your reference point. Grid position. 6-digit coordinates located within a point of 100 meters. 8-digit coordinate. 8-digit coordinates located a point within 10 meters. So again, for grid position, you have 6-digit coordinates. So what you're going to do is locate a point within 100 meters. And then with 8-digit coordinates, you're going to locate a point within 10 meters. And here's what they're talking about. RP 59850432. So you have 59 right here. Go all the way up. Here's your 8-digit number. 5985 is where your target would be. Remember, you go up and over to the right. Now, if we really want to talk about 5985 432, I'm going to go 59. Now this is actually 5985, and here's 04. But we're going to go right up here, 5904. Then we're going to go right on over to 432, 0432, and there's where your target is going to be. This is basically military, navigation, and a little bit of topographical mapping as well. And here are your topographical symbols, your man-made objects, your hard surface, heavy duty, red, brown, medium duty, red, brown, improved roads, unimproved roads, some of what you see on the legend, trail, prominent fence, single track, double track. What is this? Buildings, cemeteries. These are all your symbols that you see on the map. stream, lake or pond, intermittent lake or pond, intermittent stream. Your topographical symbols, drainage and vegetation, your tropical grass, your vineyard, your orchard, your woods, your marsh or slump. Then you have your terrain identification tests, stations. Well, shoot 2 azimuths either in mils or degrees using both methods. Given a known point, you have the idea. It's going to be either 4 or 8 digit. And they're going to be your coordinates, 4 or 8 digit coordinates. Find a base count. Given a 4 digit and an 8 digit coordinate, plot both points and ID the feature or structure. Now, there is another field that uses pacing, surveying. So you have a lot of map reading going into surveying as well. Again, your terrain features. You have 5 major terrain features: hilltop, valley, ridge, saddle, depression. 3 minor: draw, spur, and your cliff. And your 2 supplementary: cut and fill. And once again, when we deal with map reading, we're basically talking about involving the understanding of how to interpret information on a map, to plan and follow a route to a desired location. This includes understanding map symbols, scales, directions, and terrain features as we relate them to the real world. And that concludes this topic on map reading and land navigation. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some STEM content, check out my main channel, the 411 Talk Zone radio show. You can find me on YouTube. 411 Talk Zone radio show. You can find me on YouTube, X formerly Twitter, Rumble, and Truth Social. And on this channel, the QCIS channel, you can find me on YouTube, X formerly Twitter, and of course, LinkedIn. And once again, thank you for viewing this content, map reading and land navigation, right here on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.